So here we have an adapter, and this adapter is from one of HP printer, and this adapter gives 22-volt output. It can supply current maximum up to 455 milliamps. So here is the AC input port, and here is the DC output port. So the complaint is that this adapter is not giving any output. So maybe there could be some failure inside. Let us figure out what's the failure. So we'll try to open it up and see what's inside. Opening this, it's taking too much time. What I found is, I think this is a press to fit kind of enclosure, and the edges are glued also. So to remove the glue, I was just trying to use this one and one hammer. So the slowly what I have done, I have removed this all glue. So now at least the locks, if I open the lock, it will come out, but it's not yet completed. Another side I have to do the same. So you can see what's inside. I'm just trying to open it. There is too much dirt inside it. I think most of them has already come so out, and now I'm just trying to open it. See, it is still this side is opened, but this side it is still the glue, and the lock is still holding it very tight. It's not coming out. See, now here is the SMPS. So there was a glue, these are the glues, and here you can see I think there was some adhesive they have applied so that edges cannot separate easily, and there was a press to fit lock also. So see, those are the locks. See, this is, if you can see clearly, there is a glue. It was hard bonded, so somehow we have to remove those, then only it can come out. So this is how it looks inside, and there is too much dirt. I think I have to remove all those. I don't know how it went inside. Maybe it was installed in some dusty environment, so it came from there. So now we cannot take the SMPS out just like that, because this is stopping me to just take it out. So I'll remove this guy this way, and now I can take it out. You can see this is how it is. Enclosure, keep the enclosure apart, and now we have the so now we have this. So now we have this SMPS, and you can see it's very clearly something is burst here. You can see it, and seems like this is the bridge rectifier. So the output of bridge rectifier is a DC. I think there was some water droplet, I guess, and because of water droplet, this guy has got some short circuit here, and might be this was burned, and there are fuse. There is a fuse here. Maybe the fuse might have gone. So let me see. By looking at it, the physical inspection says that this MOSFET is also, I think, yeah, there is no physical damage. We can see here these all are looking good so far. The only the suspect is this bridge and the surrounding components. Let us see. So we'll first So we'll check the fuse first, how is whether fuse is broken or the continuity from the input side. So here we have the AC input, and we'll just trace it down till the bridge rectifier and till this you can see there are two caps. So we'll trace it down till the this caps, and I think very clearly you can see this trace is broken here. You can see I have cleaned it up, and now it seems like this trace is broken here. It was I just cleaned it, otherwise it was looking black. So you can see I think some water droplet might have entered here, and this has created one short circuit, so this path got broken. Let us see what's broken. So basically these are the two input points, and to reach here one wire is connected here. So one wire goes through this fuse to this point, and it again goes to this EMC filter input one end. Another end is through this white wire, it goes till here and to this one. So in parallel one cap is connected, this cap. Let us see if things are okay. See, fuse is broken. Fuse is broken, the one observation. And yes, and let us see if these things are okay from here to correct. It seems like this is good. Once it comes after this EMC filter, it 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 goes to the input of this bridge rectifier, and now the input of the bridge rectifier, it's not short circuit. Now let us see the DC link. So this is the DC link. This is positive and this is negative. So let us put my probes here. So it will charge the capacitor to create a sound when it will charge. Yes, you can see. So that's all. I think this looks good. I think only this, because of this water droplet here, this bridge is broken and this fuse is gone. If we replace that, this should work. So here we have some equivalent bridge rectifier, and let us see. Let us replace the bridge rectifier and fuse and see if it works. There is no other short circuit, as we have already tested it, and so we will repair it. We will replace this bridge rectifier. So let us remove this guy first, and then we will solder this component, this bridge rectifier. So there is a package difference. You can see that that package is very thin package, height is less. This has height more, but the pin polarity and all, everything is correct. So it should, but footprint is also correct. So we can solder on this footprint. So let us replace and see. So we will use wig to clean it up. So our pads are cleaned. So I have applied some isopropyl alcohol to clean the things. See, there is no pad at all. It's all broken. So you can see this is cleaned up, and this has good pads. Input AC has good pads, but the output, you can see the pads is all broken. So what I will do, I will use some extra lead to connect this. So now we'll repair the negative track. Positive track is already repaired, you can see that. Here we have already made the track by using a wire. Now this one will repair. So we have repaired this one. You can see the positive track is connected now, negative is connected here, and these are the two AC inputs. So we will clean it up. So repair is complete. Now the fuse is blown up, but I don't have the fuse to replace. So what I will do, I will make a short circuit. So that is not picking up, I mean it's not sticking. Lead is not sticking, so let me try another way. So I'll apply some file here. Yes, so there are signing places. I will apply the lead on the signing. So now I think it should work. Yes. So this is not going to act like a fuse. I'm just making a short. I should have put proper fuse. I should have used proper fuse wire, but since I don't have any fuse wire, so for the time being I'm just doing this. Later once I have the fuse, I will place it. So now the repair is complete. You can see here, and let us use series lamp to test it out. So here we have a series lamp, and we will connect it to. So this AC is coming from a 100-watt series bulb. So even if there is a short circuit here, just bulb will glow, nothing will blow up here. Let us see. Just connect the AC input. Let us see whether if you get output. So let us check the voltage, and we have put the meter on the 200 volt range so that we can easily measure 22 volt output. So yeah, let us see. So our output voltage we should get on this bulk capacitor. You can see here there is a secondary side bulk capacitor. So this is the negative terminal, this is the positive terminal. Let's check the voltage. We are getting 21.7 volt. We are getting 21.7 volt there, and that is correct. That is not like exactly 22.0, 21.7. So this guy is negative and this is positive. So the connector terminal voltage you can check here. It is 21.7. So I think this SMPS is now repaired and it is working good. So let us close it up everything. But you can see there are some scratches here. So we'll first try to clean it up. These scratches we'll try to clean it up, and then we will close it. So now let us assemble everything together, and hopefully this should be like working good. But before that, you remember we have removed this one at last, so you have to first put it there. See, now the AC is secured. So I think we have to do this way, not that way. Very careful. Now this is correct. This is also correct. Yeah, see, the glue is now came out, so it's not sticking up now. So now it's secured. You can see now it is secured, but it can come anytime outside. So what I will do, I will apply some quick fix here so that it should retain on its position. So we have some quick fix. Let me apply it. So let us first check if it is got repaired, and then apply the quick fix. Click on 1.7. So I think this pin is some sense pin, or I think it is not used pin. So you can see the output is at 21.7. So now we can done. Not much, I think very small quantity is enough. So now it is repaired. So now this repair is complete, and now this adapter is working fine. So now the repair is complete and this adapter is working fine. So here you can see the voltage is 22 volt, and if you measure it, the voltage here is 21.7, which is very close to 22 volt.